The final topic in this course is discounting. How do you value a future income today? Suppose you operate a business and you have investment project that pays $105 in 1 year. How much should you pay for the project today? How much should you invest? Now, is $105 in 1 year worth $105 today? Probably not, right? Probably not. Time has money. Time is valuable. If you have 100, so what's the point of committing $105 to a project that only pays you back $105 in 1 year? That means you're getting nothing in return for your money invested. So obviously that does not make sense. In particular, you could have put the money in a bank. You could have put your money in a bank, and at least you would get some interest, no matter how little it is. So it doesn't make sense that a project worth as much tomorrow as today. So suppose you put your money in a certified deposit and it pays 5% interest rate. That doesn't exist today. Okay, just for illustration, 5%, but it does not exist today in Hong Kong. How much do you need to put in order to get 105 in 1 year? Let's see. Yeah, so let's see, right? 100 times 1 plus 5% equals to 105. That means if you commit $100 in the bank today, and the bank pays you 5% interest a year, you would get 105 in 1 year. Faced with these two investment options, the bank and this other project that pays you 105, you should not pay more than $100 for the other project, right? Because if you pay more than 100, you would be better off putting your money in the bank. So for this, we can conclude that the investment project is worth 100 today. You get the idea? You have two options: bank, investment. The bank pays you 5% interest. That means that you should not pay more than 100 for that project. This idea, which sounds really simple, is actually very important in finance. Price by arbitration. This is price by arbitration. Price by arbitrage. Price by arbitrage. In finance, many financial assets are priced by this method. How? In particular, options. Things that you don't have a direct underlying value. You price by alternatives that have similar properties. That's how you do it. And in some sense, real estate is also priced in the same way. When you ask for a price estimate of a particular property, what you get is the price based on comparable properties. Right? So price by arbitrage is a very common method of pricing projects. So this is what we do. That's one. There's another thing I want to mention that I don't quite remember what it is. Okay. So never mind. I don't remember what it is. I remember what I want to mention. Now, while you don't get 5% return on Hong Kong dollar certified deposit, you do get 5% return from foreign currencies, right? Many people think that makes foreign currency a very attractive investment option. Is it not? When you study international finance, then you have studied that there's a relationship between exchange rate movement and interest rate. The reason why interest rate is high for some foreign currency is that there is an expectation that that currency is going to depreciate. And there's nothing more clear than that than renminbi. The renminbi has fallen by so much relative to the Hong Kong dollars that you would have, even despite the fact that interest rate is quite high, it's like 5%, 4 or 5%. You will have lost a lot more than that if you invest in renminbi certified deposit because of depreciation, right? So once again, generally when it comes to finance, you don't get free lunch. You don't get free lunch. Investment of similar properties should give you similar returns. That's kind of the foundation of finance. So this is called present discount value. So the worth of a future income today, is called present discounted value. And you notice how we discount it by interest rate. So 5% interest, $100, it means $105 paid after 1 year should worth $100 today. This can be expressed in the following mathematical formula. Notice the formula. 105 divided by 1 plus interest rate equals 100. By the same logic, let R be the discount rate, then the present discount value of $1 paid after 1 year is 1 over 1 plus R. After 2 years is 1 over 1 plus R squared. After n years is 1 over 1 plus Rn, and this formula is something you should memorize. Memorize it. So income in n years later is worth the income divided by 1 plus R to the power n today. Okay, this is something you have to remember. I have to remember. I mentioned it many times already. Don't blame me if you don't remember it. What discount rate should you use? This is a much more delicate question. It's not that there's no simple answer. In picking a discount rate, as I said, you have to consider what is comparable alternative investments. As for a safe project, it makes sense to use the interest rate. For example, for government bonds, that's where the interest rate comes from. But for stock market, it doesn't make sense to use interest rate because if you put money in the bank, it's safe. If you put it in the stock market, there's risk. So you can't use such a discount rate. So it's something you have to balance. If a project does not necessarily pay any return, is it reasonable to compare it to like a bank interest rate? No. So this is something when you take classes in derivatives, then you would learn more about it. How you figure out the correct discount rate. And if you're interested, for example, what discount rate should you use to calculate the return of building a third runway in Hong Kong? The government used a really low interest rate, really low discount rate, 4%, which is really low for a project that is risky. What if in the end, there's not enough airplanes using the runway? What if the runway actually does not have like other issues? 4% is quite low. So that's a question that people have asked. So more risky investment project generally carries higher discount rate. In some sense, you can try to figure that out from what type of returns that asset has. For example, as I said, bank products like mortgages and certified deposits have relatively low interest rate. In stock market, something like a 7% net return over certified deposits, and then there are personal loans, which typically has something like a 20% interest rate. So that you see that must be much more risky, right? Otherwise, the bank will need to charge such a high interest rate. Okay, so how much is $2 paid after 4 years worth today if the interest rate is 3%? Present discount value equals to 200 over 1 plus 0.03 to the power 4. Okay? So just punch the calculator. So just punch the calculator to figure out what that is, right? That's 200 divided by 1.03 to power 4. That's 177.69. Well, let's just say 0.70. Okay. So 3% interest, $200 in 4 years is worth $177.70 today. How much is $200 worth if it's paid after 8 years instead? 200 divided by 1 plus 0.03 to power 8. Right? That's 200 divided by 1.03 to power 8. That's 157.88. So the further the money comes in, the longer you need to wait. Obviously, the less the project would have worth today. Time is valuable. What if you have high interest rate? High interest rate, 4 years, right? So that's 200 divided by 1.05 to power 4, 164.54. Higher interest rate also means, higher interest rate also means that the value today is lower because the alternative is more attractive, right? Remember, we are pricing a project by how much money we can get from putting the money in a bank account. If the bank account pays a higher interest, that means we need less money today in order to reach the same return in the future. That would lower the value of the project. This is something that, in fact, you might have heard of. Bond price move in the opposite direction as bond yield. Bond yield is the return. Bond price is the price of the bond today. Bond price and bond yield moves in the opposite direction. Interest rate goes up, bond price goes down. That's the way it works. Okay, so the math, you have to remember how to do the math. Then what? Okay, so the formula for computing the value of a future stream of income is this formula. The present discount value equals to income in year 1 divided by 1 plus the interest rate plus the income in year 2 divided by 1 plus the interest rate squared, and so on and so forth. This formula is easy enough to apply for a few years. For more years, it's a bit difficult to use. So fortunately, in many cases, if the income is constant over the years, which is the case for many products. For example, when you take out a mortgage, you pay a fixed sum to the bank every month as long as the interest rate is constant. And for some bonds, the bond promise to pay you a fixed amount usually every 6 months for a certain number of years. So in many practical cases, the income X each period is fixed. In that case, you can actually derive a very simple formula. The present discount value of having n years of income is the income amount divided by the interest rate times 1 minus 1 over 1 plus the interest rate raised to the power of the number of years. So once again, this is a formula that you simply memorize. or enter into your calculator or enter into your spreadsheet, something that you just use. But I'll show you how this is derived. It actually makes use of the sum of geometric series that you have learned in secondary school. Okay. So we start with asking what's the value of a investment that pays you the same amount forever, right? From now till the end of the world. Well, that's x divided by 1 plus r plus x divided by 1 plus r squared plus x divided by 1 plus r cubed and so on and so forth. Now, if you take out 1 over 1 plus r, that leaves you with x plus 1 over 1 plus r x blah 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 blah. That is a geometric series, right? The sum of a geometric series. And you have learned that if you have a sum of geometric series where you have like something like what? A plus a times r plus a times r squared and so on, that simplifies to a over 1 minus r, right? As long as r is smaller than 1. You have learned that, right? So, the numbers inside the square bracket will follow that because r is interest rate, is positive. 1 plus a positive number is going to be bigger than 1. 1 divided by a number bigger than 1 is smaller than 1. So 1 over 1 plus r thus is smaller than 1, and you can use the formula for infinite sum of geometric series, and the whole sum inside the square bracket becomes x over 1 minus 1 over 1 plus r. So that's just high school mathematics. And simplified, that gives you a very simple formula. If you have an infinite stream of income, then its value is simply the income you get each period divided by the interest rate per period. Very simple, right? So, for example, if you are getting $10 forever, and the relevant interest rate is 5%, right? That's 0.05, then the value is 10 over, so let me write it down. Right? So your income is 10. Let's say interest rate is something like 5%, right? Then the value of this income, which lasts forever, is x over r, which equals to 10 over 0.05, right? And 0.05 is 1 over 20, which means this is worth 200. This formula itself is not of practical use because no actual financial products pay you forever, right? I mean, you die, so it can't pay you forever. For the most common type, for products which pays you somewhat fixed amount, like bonds, 30 years is kind of the longest you usually see. You don't really see something. You don't really see things like 50 or 100-year bonds that often. Not that many people are interested in them. So 30-year bonds are quite kind of the maximum you see commonly. So this formula is not very useful because it's just giving us the value of a bond or an investment that pays us forever. However, this formula helps us to find the formula that does calculate a value for a finite number of years. Okay, so how do we do that? So how do we get from a formula which gives us the value for infinite stream of income to a formula that only gives us the value for the first n years? Okay, so the idea is, now a project that pays for n years starting next year is identical to a project that pays to eternity starting next year minus a project that pays to eternity starting at the n plus 1 year. This is one of the interesting property about infinity, right? You can go from now to infinity, and you can go from sometime in the future to infinity, and if you subtract the second from the first, you're left with only the first periods. that we are interested in, right? So you basically essentially subtracting x over r with x over r, but appropriately discounted. Okay, so you're subtracting the red part from the black part, the overall black part, and that would leave you with the part in the front, which is what we're interested in generally. Because, as I said, actual financial products have finite durations. Okay, so this is what we want. Let's see how mathematics goes. Okay, so we know a project that pays from next year to eternity would be worth x over r. That's what we just derived, the sum of geometric series. A project that pays from year n plus 1 to infinity, we have to discount by the number of years we have to wait before we actually start getting the money. And each year we discount by the interest rate out. So each year you have to divide by 1 plus r. And for n number of years, you have to divide by n1 plus r to the power n. So the red part is worth x over r divided by 1 plus r to the power n. Okay, so this, now, it's important to note that the red part, if you are actually standing at the middle, you're standing at n plus 1 years from now. So in the future, the red part actually worth x divided by r. In the future, when you do not need to wait for that money, the money actually start rolling in, it's worth x over r. But today, because you have to wait so many years before you actually start getting the red part is worth a lot less. And it's only worth x over r divided by 1 plus n to the power n, plus 1 plus r to the power n. Okay, that's what it's worth today. And that's what you're going to subtract from x over r. So that's what you do. X over r minus x over r divided by 1 plus r to raise to the power n, and that gives you the formula that gives you the value of a project that pays you n years. So this is a formula that's called, I'm not too sure. It might be built into Excel already, because this is commonly used. There are some variations in this formula that we'll talk about in a moment. And basically, now this particular formula assumes that each year you get the same amount of money. For actual financial products, many of them pays you more at the end. Like every year or every 6 months, they pay you some interest or dividend. At the very end of the duration of that product, you will get a large sum of money back. So you would have to add that to the value discounted if that's the product you are talking about, which I think we're going to talk about in a moment. Okay, so this is a formula that you should remember too. Just all right, so let's just apply the formula. Okay, so $1 paid forever worth is, so that's 1 over 3%. That's because this is paid forever, right? So that's 1 over 0.03, which is what is that? That's 3 over 100, right? Okay. $1 paid for 10 years, right? $1 paid for 10 years. This one, you just use the formula. What? Oh, sorry. This is hard math. Wait. It's 100 over 3, right? Okay. Yeah? Yeah? That's why I am the one writing the exam and you are the one answering the exams. What? Yeah. I like this. We get the solution. We get the solution from based on your answers, right? So. $1 paid for 10 years worth if the interest rate is 3%. So this it's going to be 1 over 3% multiplied by 1 minus 1 over 1 plus 3% raised to the power 10. And this is something you just have to punch the calculator for, right? Okay, well, you can do it, right? So, and this is 1 over 3%, 1 minus 1 over 1 plus 3% raised to 20. Okay, so you just use the calculator if you remember the formula. Okay, so now I'm actually going to talk about some of the properties of real financial products. Financial products that pays you a sum of money for every period of once in a while, for every once in a while. Okay, a financial product that pays you an amount every once in a while. They are called fixed income securities. Fixed income securities. So this is usually a department in investment bank, right? So in investment bank like Goldman Sachs, Morgan Stanley, you have various departments. The most famous one is usually the investment bank department, which deals with mergers and acquisitions. This is the best paid department. That's where like the brightest students in finance wants to go. IBD. Besides IBD, you have traders, which handles trading activities, right? You have operations, which handles the back end details in our actual operations of trade. Then you have people who engage in different types of, and you have analysts, right, which do research. And within each category of products, you would have things like equity, which involves stocks. You have private equity, which involves stocks that are not publicly traded. And then you would have fixed income securities, which involves things like bonds. So fixed income securities have a few properties. First, maturity. Maturity is the date in which a fixed income security contract ends. Now, as I said, you rarely see things longer than 30 years. US Treasury bonds goes to 30 years. That's kind of the longest you commonly see. But it can be very short. The US Treasury bills, which would be the most widely traded government bond, they have 30-year bonds, 10-year bonds, 1 year, 3 months, and the shortest I think is 1 month. Right? So it could be very long. It could also be somewhat short. Maturity is how long it lasts. Face value. Face value is also called a par value. This is the amount of money that the borrower promised to pay the lender at maturity. So the way it works is, if you buy, for example, the US Treasury bond, the way it works is the US government promised to pay you $10,000 after 10 years. Then it solicits bids. How much are you willing to pay for the right to get $10,000 from the government in 10 years? So the base value is the $10,000. The government promised to pay you $10,000 after a certain amount of time. That's the face value. Coupon. Coupon is the regular payments made before maturity, usually quoted as a percentage of face value, called coupon rate or coupon yield, and paid semi-annually. Okay. Not every fixed income product would pay you a coupon. Some of them pay you nothing until the very end. Conversely, not every fixed income product have a face value. there are products which have no face value, it only pays you coupon. Okay. Worse, there are financial products which have no face value and no coupon. Those are also fixed income securities. But it's a very weird kind of fixed income securities which only happens in very specific instances. So think about it. So it's still called a bond. It's still called a bond, but it has no face value and no coupon. That means you don't get any of your money back. Why would anyone buy such a product? You do pay money for it. Anyone have heard of this kind of product? Yeah, if you read the news, you might have heard of it in Hong Kong. You don't get money, you don't get any payment in between, nor do you get any payment in the end. So you really don't get your money back. Yet people do pay money to buy them in Hong Kong. Anyone read the news? Anyone have read it? Any of you are from local international schools in Hong Kong? None of you from international schools? International schools in Hong Kong are in short supply. So a lot of parents want to send their kids in, but you just can't get in like that. Schools typically ask you to essentially pay money in order to get in. And the way it works is you buy school bond. You buy a bond from the school. The bond pays no interest, so no coupon, nor does it pay you, nor does it has a face value. So essentially what you do is this. You pay something like $500,000. You pay $500,000, your kids get into the school. When your kids graduate, the bond expires, you get nothing back. So essentially it's a payment to get your kid into the school. But it's structured as a financial product, namely a bond. So there could be financial products which have no face value and no coupon. It's still a bond. It's still a bond. So finally, the price. The price is the price of the product right now, usually quoted as a percentage of the face value, right? So as I said, the most common example would be US Treasury bond. Given that the government promised to pay you back $10,000 in 10 years, how much are you willing to pay for that right now? Now, obviously, you're not going to be willing to pay $10,000, right? There's some value to holding actual money now, so something that pays you back $10,000 in 10 years, you probably may be willing to pay something like $7,000 or $7,000 maybe, right? I think $7,000 is kind of like a fair value for that. Okay. So that's the price. So the common types of fixed income securities: zero coupon bonds, only pay you a fixed payment at the maturity, no coupon. The prime example being US Treasury bills. So US government debt are separate into two types: T-bills and T-bonds. T-bills are short-term, T-bonds are long-term. So things like 1 month and 3 months, these are called T-bills, and they don't pay anything in between, right? It's just 1 month. So obviously, the government's not going to pay you anything. So these only pay you back the promised amount at the end of the duration. Coupon bonds make a series of coupon payments up to and including the maturity date, then pays the face value. US Treasury bonds is an example. So US Treasury bonds starts at like 1 year, 10 year, 30 year, and so on. Okay, so these actually pay you money in between. It's 30 years, right? If the government pays you nothing in between, it sounds like a very unattractive investment. So it does pay you something in between. And finally, mortgage. Mortgage is kind of the opposite, because mortgage is you selling a product to the bank. If you think about it this way, right? The mortgage is you selling a product to the bank. The bank gives you a pile of money for you to buy some property. you promise to pay the bank some money every single month. So the monthly mortgage payment is the coupon. And typically there is no face value because after 20 or 30 years you have paid off your mortgage, you don't owe the bank anything more. Right? So there's no final payment. So these are different types of fixed securities. And that's why you see, right, why mortgage is also could be part of investment bank's business, because it's a kind of fixed income securities. And if you have read into the last financial crisis, you know mortgage is one of, well, it's the reason of the reason of the crisis, right? So this is fixed income is the important part of investment bank business. Right, so let's read the back in even smaller types. Right here, what does it say? What I want you to see is, so the second line, the actual annual interest rate is the actual annual interest rate are 5.63%, 5.81%, and 5.83%, and 5.82% respectively. So the key is the actual interest rate. The actual interest rate is somewhere around 5.8%. But how do you get the number, right? There's no interest rate. There's no interest rate to say, but there's a handling fee. The handling fee is 0.18% per month. How do you get a 5% interest, 5.8% interest from a 0.18% interest rate per month? How do you do that? No matter how you multiply, it doesn't sound possible, right? 0.18 multiplied by 12 is just 2.16. Even if you multiply by 20, it's still nowhere close to 5%, right? So how do you actually reach the 5% real interest rate? All right, here's how. Okay, so for example, if you borrow $10,000 to be repaid in 1 year, the monthly interest rate about the processing fee, this is really interest rate. So in some sense, like, okay, so it's a bit misleading in the way that the advertisements are written, but in government regulations, they do include handling fee as part of the interest rate. So all payments are included in calculation of interest rate. So we just call it interest rate. The quoted yearly interest rate is like 5.63%. Simple interest rate, no, it's free, like 0.25 times 12 is 3%, nowhere close. Is it compound interest? No. Well, it's true that compound interest is going to raise it, but it's a 1 year of compounding. It's not going to get you anywhere close to 5%, 5.63%. It's still just 3.04%. So that's not it. So what's going on? Okay, so here's what's going on. When you choose to repay in 1 year, right? You take money out now, you repay the money in 1 year. The bank calculates interest for the whole year, right? So typically, when you take out a personal loan, the bank would ask you, like, okay, so let's work on a payment scheme. You borrow $10,000, you would pay it back starting from next month. It's just like a mortgage, right? You borrow some money, you pay it off in installments, right? Starting from next month. Okay, that's the way it works. The thing is, the bank calculates the interest for the whole duration, for the whole sum. So you borrow $10,000. Let's just forget about the interest rate right now. You borrow $10,000. You repay $1,000 next month, right? That leaves you with only $9,000 balance. Then you pay off another $1,000. That leaves you with $8,000 balance, right? In half a year, you only have $5,000 left. That means you're owing less and less money. So for most of the time, you're actually not owing anywhere close to $10,000, correct? Because you're constantly repaying the money. Except that's not how it works when it comes to calculating interest for your loan. When it comes to calculating interest for your loan, it's assumed. Well, the way it works is the $10,000 is you are assumed to be borrowing the $10,000 for the whole year, regardless of when you're paying it back. So the interest rate for the whole $10,000 is going to be charged at 1,200. So you're required to prepay a constant amount every month starting from next month, even though you have been charged interest for the whole year, for the whole amount. The actual yearly interest rate is calculated from with our present discount value formula. This formula is the formula that is used. Now this information is very hard to come by if you are an uninformed consumer. I've tried. It states in nowhere that this is how it's calculated. All you would see in the advertisement is that the annual interest rate is computed according to the bank, according to the banking associations defined the formula, blah 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 blah. But you can find it nowhere online what the formula is. You can't find it. So unless you are trained like you are now in like economics and finance, you wouldn't know how come they could have charged you that high interest rate. The reason is the banking association calculates with the PDP formula. And because you are constantly repaying some money, right? So the bank says, okay, I'm going to charge you this. I'm going to charge you 2% interest out of $10,000. That's $200, right? But remember that throughout the year, your balance is reducing, which means the $200 out of your remaining balance is becoming a higher and higher percentage. So that leads to the higher actual interest rate. That's why your interest is calculated for the whole year, but you are constantly repaying money. So, if you want, in case anyone plans to take out personal loans in the future, and I would say a good advice is don't. It's so expensive, just don't. Although, if you are facing a choice between cash advance from credit card and personal loan, then by all means, take the personal loan. That's way cheaper. So, if possible, use your own cash, right? Otherwise, maybe find a friend or family member before you go on personal loan, right? Personal loan charge you something like 6% interest, which is quite high. But never, ever use credit card cash advance, because credit card cash advance charges something around 25 to 35% interest a year. So never use it, okay? And that's also why a lot of people use personal loans to pay off credit card debts, because even though 6% is quite expensive, it's way cheaper than 35%, right? So that's why people use it. And that's also why banks are so willing to offer personal loans. 6% interest. What's the interest rate of your money in your bank right now? 0.1%. So 6% versus 0.1%. I think the choice is quite simple for most commercial banks, which have a lot of cash in their hand. So the formula to calculate the actual yearly interest rate is as follows. The money lent out it's the same formula. It's the x over r times 1 minus 1 over 1 plus r to the power n. So this is the formula. R is the actual monthly interest rate. So this is the number. This is the small number in the back of the leaflet. This is called the internal rate of return for the loan. You can calculate with Excel solver. You can't do it analytically. You have to use Excel solver to do it. The actual yearly interest. So the actual yearly interest rate is 1 plus r to the power 12 minus 1. Okay, so for example, let's say you borrow $10,000. Repaid in 1 year. Oh, okay, so I'm actually supposed to switch to Excel, but
we don't have time for that, so let's not do it now. Just remember, personal loans are very expensive. Okay, so I have 4 minutes, so I'm